Test A on Chapter 4. First, we're supposed to find R6, where v is the velocity, and the velocity is in meters per second, and time is in seconds. So if I'm finding the area under the curve, I'm taking the heights times the width, which would be seconds times meters per second, so I'm going to get meters. And R6, so I have to divide this up into 6 intervals. 1, 2, 3, 4, 5, 6. So there are 6 already. And they're intervals, not places. And so I have to find the height on the right side of this first one. Well, it goes at 0, it's at 35, and at 3, it's 33. And on the right side, it's the 33 that counts. So I'm going to use 33 times the gap, which is 3 seconds. Then I'm going to use gap is again 3 seconds, but I've got a height of 33 and 21, and I'm using the right side, so it's the 21. And then on the next one, the right side is 16. And on the next one, the right side is 10. On the next one, it's 7. And then it's 5. So I have 3 times, this added up is 92, and 3 times 92 is 276, and that would be meters. Now B, I'm doing the same number of intervals, 6 of them, but this time I'm doing it on the left side. So instead of using the 33, I'm going to use the 35 times 3. The width of the intervals are all 3. I'm using 35. The right side of the second interval is 33. Left side is 33. The left side of the next one is 21. The left side of the next one is 16. And the left side of the next one is 10. And the left side of the last one is 7. And there's 1, 2, 3, 4, 5, 6. So I have 3 times 122, which is 366 meters. Now the midpoint, and I said 3, and it's a good thing I did, because if I did 6, I wouldn't know the midpoint. Now the midpoint of this interval is at 33 height. 35 on this side, 21, and 33. 1, 2, 3 intervals. So each interval is going to be 6 wide. 0 to 6, 6 to 12, 12 to 18. But these are the heights. And the height we're using is the one in the middle, 33. The height in the middle of this one is 16. Remember, velocity is the height. And in this one, the height is 7. So I have 6 times 56, which is 336 meters. And finally, we got to do the Trapezoidal 6. Now, you can do it the long way, which means you're going to take 6 of them. So we're going to go back to those original intervals, which are all 3 wide. And you're going to do the average of the two heights, 35 plus 33 over 2, plus 33 plus 21. So you're using the average height of each of the intervals. Average of those, average of those, average of those, and so on down the line. But that's exactly what you get if you just take R3 plus L3, or in either order, or 6. No, T6, 6. L6 plus R6 plus L6 divided by 2. just add these two up and divide by 2. So you got 276 plus 366 divided by 2, which turns out to be 321 meters. Okay, number 2. We're supposed to do 4 rectangles between 1 and 3. 1 and 3 looks like each one would be a half wide. And we're supposed to do one which gives us a low value, which means since this is a decreasing function, my explanation, so low is on right side, or putting it on the right side, which looks like it's right about there, that leaves some out. There's missing. And each one of these will have some missing. So your estimate at the height will be maybe different than mine, but each one is a half wide. And my estimates are, let's see, about 2.9, about 1.5, about 1, and about 0.9. And if I work that out, I get 1/2 times 6.3, and these are approximate, which is approximately 3.15 for the area under the curve. And it's decreasing, so I'm using the right side, or I could say using right Riemann sums doesn't get all the area on a decreasing function as shown. Okay? Something like that. Okay, on this one, so now the snow is accumulating on the patio, and F of t is the rate of which the snow is falling, because the derivative gives you the rate. And F, capital F, is how many inches at the time that it's given. And the time is based on 12 noon, so this is 5 hours after noon, which is 5 p.m. There's 6 inches, etc. So we're supposed to find out how much snow at 7 p.m. Well, this one talks about from 7 to 9. The area is 2, which means the 2 inches more accumulated from 7 to 9. Well, if we use that, and at 9 it's 14, and back off, 14 inches at 9 o'clock, backing off the 2 inches that came on, that gets us to, there were 12 inches of snow at 7 p.m. So I've got a value, 12 inches, units, inches, and I explain the significance. That's the amount of snow at 7 p.m. B, from 3 to 7 afternoon, so 3 p.m. to 7 p.m. How much snow accumulated, because this tells you how much there is a change. So at 3 o'clock there was 5 inches, and at 7 there's 12. So went from 5 to 12, so that's 7 inches more snow, or 7 inches of snow added between 3 p.m. and 7 p.m. C, how much snow was there at 1:30 p.m.? This one has 1:30. From 1:30 to 5.5 inches accumulated. At 5 there were 6 inches. So if you back off 5.5 inches, it must have been at 1:30 p.m. there was 0.5 inches. Because we're taking 6 minus the 5.5 that was added to get to 5. And finally, 5 to 7 and 7 minus 5. So those are the hours. So we have 1 over 2 hours times, and this will be the amount of snowfall between 5 and 7. Between 5 and 7, see, that's from 5 is 6 inches, and at 7 there was 12 inches, so it gained 6 inches in the 2 hours. So we've got 3 inches per hour. So the correct units are inches per hour, and it's the average rate of snowfall. Doesn't mean it snowed 3 inches each hour. It could have snowed a lot and then a little in the second hour, but over the 2 hours it averaged 3 inches per hour. Between 5 p.m. and 7 p.m. Okay, now an even function, what happens on the left side of the y-axis happens on the right side of the y-axis. So if I make a graph here, and from 2 to 5, we get 11. So that's a positive amount. So that means between -5 and -2, it's also 11 on an even function. It's symmetric. It says between -2 and 5, there was -7 inches. So if this plus 11 is -7, there must be -18 in here. And if it's even on both sides, it must be -9 and -9. So now we're ready to answer the questions. So from 0 to 5, we have -9 plus 11, that's +2. Between -5 and +5, that's +2 plus 2, so it's 4. Between 2 and -5, that's going backwards, so it's going to be the negative of whatever from minus 5 to 2 is, and that would be 11 minus 18, which is minus 7 going this way, so it's plus 7 going the other way. Okay. 5a. So this is a power rule, so you add 1 to 2, which is 3, and we divide by 3. So 3 divided by 3 is 1x to the third. Derivative of this, 3 times x to the 2. That's what we have. This is x to the 1/3, so adding 1 to that is x to the 4/3, and dividing by 4/3 is the same as multiplying by 3/4, and it was a negative. Subtract there. And then 5 cosine. Cosine is the derivative of sine, so this must be plus 5 sine x. And since we're going for the general, it's plus c. The derivative of this will equal this. This one, we don't know how to undo a quotient rule, but we do know that we can bring this up and call it x to the minus 1/2. Now, if you distribute this, when you multiply, you add the power. So 2 plus a negative 1/2 is x to the 3/2. I should write that over here. X to the 3/2 and minus 7x to the minus 1/2. So now, to do the power rule, we add 1 to 3/2, which makes 5/2, and we have to divide by 5/2 or multiply by 2/5. So that's the antiderivative of that. The antiderivative of x to the minus 1/2 times the number stays. So you have to increase minus 1/2 by 1, which changes it to x to the plus 1/2. And then you have to divide by 1/2, which is the same as multiplying by 2. So 7 times 2 is, and it's negative, 14, plus the constant because we're going for the general. This one, you can't do separately because there's a quotient rule involved, but if you think of it as this thing, bringing the x to the minus 2 up as x, or x to the 2 up as x to the minus 2, we can then use the power rule on this. The 5/3 stay. Adding 1 to minus 2 is minus 1, so I get x to the minus 1, but I have to divide by my new power, minus 1. Well, dividing by minus 1 is the same as multiplying by minus 1, so I get this, plus c, or negative 5/3 times 1 over x plus c. Now, some of you said, oh, 1 over x, the antiderivative of that is ln absolute value of x. But I already took the antiderivative getting to here, so I'm not taking the antiderivative twice. I'm done right there. This one requires you to recognize that this is just 7 times 1 over x squared plus 1, and you should have on your note card that that's the derivative of the arctangent or tangent inverse of x. So we have 7, the constant follows along, so 7 times the tangent inverse or arctangent of x plus the constant. And this one, the antiderivative of sine x is not cosine x, because the derivative of cosine x is negative sine, so it's negative cosine x to make it a plus sign. And the antiderivative of cosecant squared is a negative cotangent plus c. All right. Now, what exact answers on these? So, x to the minus 1 is 1 over x. 1 over x, the antiderivative, is ln absolute value of x. And the derivative of sine is cosine, so we just have to write negative sine x, because then the derivative of negative sine x is negative cosine x. And then you put the evaluate at the end here, and we're going from 1 to 3 of the antiderivative. You don't put 1 to 3 on the original stuff. And that will equal, we've got to put in 3, and 3 is positive, so I don't need the absolute value anymore. It's going to be ln 3 minus sine 3 minus, then we put in 1. Ln of 1 is 0, so I could write that, or I don't have to write it, and then put in 1, and it's minus sine of 1. And you'll want to make sure that you put your calculator in radians if you want to check your answer on this. But this is an exact answer. Any calculation of this on a calculator will give you a decimal approximation, not the exact answer. On this one, absolute value of x minus 2. So you should know what x minus 2 looks like. It's a line going through minus 2 with a slope of 1. And so by 2, it's crossing the line, and by 5, it's up to 3. So, to do this one, this is negative area, but the absolute value would actually flip it up this way. So we got this area and this area. Now, if we do the integral of x minus 2 from 0 to 5, it's going to subtract this from that and give us the wrong answer. So we have to do the integral of x minus 2 from 0 to 2, integral from 0 to 2 of x minus 2, but that's going to be a negative value, and we have to change it to a positive. Plus, then from 2 to 5, we can just use the x minus 2. It'll be the integral of x minus 2 dx from 2 to 5. Now, the integral, the antiderivative of x minus 2 is 1/2 x squared minus 2x. We're going to evaluate that from 0 to 2, and we're going to take the negative of it. And then we're going to add to that, the antiderivative of x minus 2 is 1/2 x squared minus 2x. We're not going to change the negative to negative on that from 2 to 5. Now, if I put 2 in here, I get a negative, and that's 4 times 1/2 is 2, minus 2 times 2 is 4, and then minus a minus, so it would be plus, but if I put in 0, I get 0, because I'm supposed to subtract, but that minus makes it plus. But it's 0 anyway, so I don't have to worry about that. Plus, if I put 5 in there, I get 25 over 2 minus 10, and then I put in 2, so subtract, and I get 4, half of 4 is 2, and 2 in there is minus 4, and I'm subtracting the whole quantity, so I have the parentheses. So 2 minus 4 is minus 2, and a minus makes it plus 2. That's the area of this part, 2. That's this area. And then here, 25 over 2 is 12.5 minus 10, so it's 2.5 minus a minus 2, which is plus 2, so that's 4.5. That's this area. So my total area is 2 plus 4.5, 6.5, or 6.5. And that is exact. Even though it's a decimal value, it's exact from this. Now this one, the integral of e to the x, of course, the antiderivative of e to the x is e to the x. The antiderivative of a constant, pi, if it was 2, it would be 2x. If it's 5, it's 5x. If it's pi, it's pi times x. And we're evaluating from backwards here, 5 to 2 instead of 2 to 5. So I got to put the 2 in first, and I get e to the 2 minus 2 pi minus e to the 5 minus 5 pi. And that's an exact answer. With these irrational numbers in there, the e and the pi, not much you can do. Now there is a little. The minus 2 pi plus 5 pi we can put together and make 3 pi. But e to the second and e to the 5 are different numbers. You can't really combine those much. And so it's going to be plus e squared minus e to the 5. That would be the exact answer. Number 7. So the antiderivative of this, because we're going for capital, so that's the antiderivative of the small case. So raise the power 1 to 2 and divide by 2, so we get t squared. Raise the power by 1, which would be 3, and divide by 3, so the 3's cancel, and I get minus t to the third, plus some constant is what f, capital F of t has to be. But with this, we can calculate the c. If I put in 2, I get 4 minus 8 plus c, and it's supposed to come out to be negative 2. 4 minus 8 is negative 4, so if I add 4 to both sides, I get c equals 2. So my final equation for f of t, capital F of t, is t squared minus t cubed plus the c. Okay, if this is a velocity graph in meters per second, and this is in second, then the area would represent how many meters. And if I look at just one box, it's 2 wide and 3 tall, so this is worth a negative 6 meters if I want to count boxes. Or I can do the triangle formula. Now, if this is 2, 4, that would be 5. So I got 5 by negative 15. So that's negative 75, but only half of that. So negative 75 halves. And to here, that's again 5. And it is 15 high. So it's basically the same as this, and this, but it's positive, so it's positive 75 halves. And I'm supposed to stop at 14, which is here. It said after 14 seconds. And while this side is 15, this side is 9, and the average of 15 and 9 is 12, and it's 4 wide, so this is 48. So relative to its original position, it went backwards, so left that much, then it got it all back, and then it went 48 more, so it's 48 meters to the right. And then determine the total distance. So we don't care that that's negative. It traveled that distance, so we have half of 75 plus half of 75, so that's a total of 75 meters plus 48 more meters. So that's 100, let's see, 13 and 111, 123 meters, I believe. Let me check my arithmetic here. Yeah. Okay, this one was a challenge only because of the negative signs. So we have to put in -1, 0, 1, 2, 3, 4, and 5. That's going up by integers from -1 to 5. If I put in -1, I get 1 plus 1 plus 1. That's 3. Because -1 squared is 1, and the negative of -1 is 1, and so I get 3. If I put in 0 for the i's, I get 1. If I put in 1 for the i's, I get 1 minus 1 plus 1, which is 1. If I put 2 in for the i's, I get 1 minus 2, which is minus 1. And then 2 squared is 4, so minus 1 plus 4 is 3. And if I put 3 in, I get 1 minus 3, which is -2, and 3 squared is 9, so that's 7. If I put 4 in, I've got 1 minus 4, which is -3, and 4 squared is 16, so -3 plus 16 is 13, and finally if I put 5 in, 1 minus 5 is -4 plus 25, which is 21, and these all add up to be 49. And finally, this looks like perfect squares. 2 squared, 3 squared, 4 squared, up to 9 squared. So I probably want to make I go from 2 to 9. Some people did 1 to 8 and said I plus 1, which you could do. Make it I plus 1, quantity squared, and go from 1 to 8. But 2 to 9 of I squared works.